Right. And where is the actual presentation area? Is it this way? Hmm. I seem to have lost the ability to turn on desktop. Like you know how there's like the click to like rotate the camera, that has stopped working. Yeah, no, I can still navigate with keyboard, but I think I accidentally like right clicked while I was dragging, and that might have messed something up. So I will quickly refresh here. All right, there we go. Yeah, you had like just launched this, I think. Yeah. Oh, nice. Ooh. Is he actually going to share that IK solution? You do appear to be floating higher than everyone. Oh, Nori, there you are. Hmm. Um, there's a couple people out in the opening area still, but yeah, I think we got most of everyone. All right. I'll just put myself here. Yeah, I was also noticing that. I think I remember a similar issue, but with like, I remember the colors also messed up last time. I'm the Meetup camera. Do you see me? I'm like right in front of the screen. I'm right here. Hello. You can you can't see or hear me? Hello? Hmm. Can I really not? Okay, so you can hear me. Am I just quiet? Is that what it is? Okay. Yes. Yes, that is where I am right now. My headset's dead, so I can't use it right now. Okay, but yeah, feel free to begin your presentation whenever. Oh shoot. Hang on one sec, Jonathan. Sorry. Uh, I think there's a stream audio issue I need to fix real quick.
Engine yet?
Oh, I can see hands.
Yeah, Kaita is Keith. Nice.
Okay.
But all right.
All right. I think we should be good now.
All right. So welcome everyone. Thanks very much, Daniel, for allowing us to, first of all, host the meetup and then be able to present here about Wonderland Engine, which of course, hopefully most of you know Wonderland Engine is the development platform for WebXR, which effectively originally 5 years or 6 years ago, I designed specifically to be able to build highly performant WebXR applications that run well on every device and today also run 3D on the web, even on iOS, which is a particular problem on WebGL. We just are preparing a Wonderland Engine A to Z course, which we are going to launch in, let's say, 2 weeks roughly. And there's going to be a very early bird discount, which you will get if you subscribe to the newsletter. So I would appreciate if all of you go after the meetup, of course, not now, and subscribe to the Wonderland Engine newsletter at wonderlandengine.com, and then you'll get note whenever we launch the Wonderland Engine A to Z course, early bird, and I'd be happy if you get a chance to try out Wonderland Engine and learn a bit how to use it. Especially if you're coming from Unity, it's going to be pretty intuitive. But other than that, Stephen today is going to present Wonderland Cloud, which is our cloud platform for multiplayer and hosting and much more. He's going to explain that. He's a solutions architect with Wonderland Engine, which means that he helps clients and our internal projects as a developer using Wonderland Engine. Thank you very much, Stephen, for taking care of the presentation today, and I hope you all enjoy.
Awesome. Thank you, Jonathan, for the warm welcomes. So, yeah, I'm going to get into the presentation mode now. So, yeah, good day, everyone. And Jonathan did the introduction for me. Like he said, I'm a solutions architect at Wonderland Engine. And yeah, today I'm very excited to share you our experience for building this cross-platform multiplayer WebXR demo with Wonderland Cloud. So yeah, he did give a brief explanation as well on Wonderland Engine. As I said, it's a highly performant engine specifically tailored for web and WebXR. And when it pairing it with Wonderland Cloud, it can open up incredible opportunity for making multiplayer or metaverse kind of solutions. So let's look what are its key features. Okay. So with that, with Wonderland Cloud, we can write custom server code, which means you are in control of like what runs on your server. which gives you unparalleled flexibility. And you can get optimized spatial audio. This is kind of a big deal because many services struggle to handle spatial audio kind of effectively. So one-line cloud take care of all the heavy lifting by mixing the audio on the server so that user only receive the end result, ensuring smooth performance. Then it comes with this inbuilt rapid development workflow. You can live debug the servers. I mean, you can just change a line of a code and you can instantly see the change reflected in your server. And yeah, I would like to share some of the success stories dramatically. So the first one, it actually happened right here in the WebXR community almost a year ago. Multiply WebXR demo in the exact same WebXR meetup space. It was a good start, but it had its own share of glitches. It still has, but still, back at the time, it got some inverted hands and small crash even. But overall, it was a start, and it was okay for that. But fast forwarding today, it has changed quite a lot. I would like to discuss what they are. So we refined the system through some of the collaborations with one with Nick Trevor from Indie Tours. So we created a VR tour experience for their audience. It was quite fulfilling to watch them having. Then came our partnership with Arthur for the Francophone WebXR meetup, which is a French version of the same WebXR meetup, which was, I would say, like one of the most successful meetings. We hosted like up to 30 participants in the event there with zero crashes as well. So kind of a testament to the platform stability over the time. So getting started, like if you're someone like me who would like to dive into examples, we got you covered. You can head to, or you can just search like the one-line cloud examples in the Google, and you can find examples, one with bare bones, I mean, just the networking code, and one with a complete example, just like this one, with avatars and this virtual machines and everything. And as for pricing, also you can go to cloud.oneline.dev to create your own servers and also to get the documentation of like how all these things work under the hood. So you want to develop on it, then you want to know, I mean, how I can get into it. So we have to get into pricing. So we got a free tier. I mean, if you want to just try it out, like I want to test it if it's a good fit for me or not, you can just try with the free tier. It's perfect for developers. Um, we got a catch though. It only runs the server for 5 minutes or so. So if you get a hang of it, like how the server works, if it's fit for you, then if you want to like move on to production, then you can start with this starter plan, which only start for $5 per month. A very budget-friendly option, I would say. It also has this panning feature, so simulate this kind of spatial audio, but in more performance friendly way, and also as like a faking. And if you want to go to the state of the art spatial audio and immersive experience, then you can opt for this $20 plan, which comes on the top tier. So yeah, with that, let's summarize why Wonderland Cloud. Okay. So one thing I'll very much like about it is its cross-platform compatibility. Jonathan here today joined with a mobile phone, and some of people here are using VR headsets, and I'm joining from PC for sharing. So it works truly magically on all devices. It's one of my generic quality that I like about WebXR as well. And we can provide custom server logic via TypeScript or JavaScript, whichever language you prefer. I really nudge you to use TypeScript, by the way. And also you can get this inbuilt spatial audio, HRTF, and we got rapid iteration with this live server, and it's highly scalable, which we load tested with the previous events for up to 30 plus users, and it's quite affordable even for developers and for base production, and very easy to set up with this GitHub examples. So yeah, I guess that's it. I mean, Jonathan also covered this A to Z courses in the beginning. So thank you all for listening. And now I open the stage for any further casual discussion or Q&A. I think I haven't lost anyone here.
I think we're still here.
Yeah.
Awesome.
We need a clap button like Mozilla Hubs had.
Yeah.
Yeah.
Still has.
Definitely.
We still have it.
We have audio.
It's just a little more manual
Yeah,
than the Hubs one.
Yeah. Speaking of that, can you speak to future roadmap? What features are in development, planned for development? Give us an idea of that.
Sorry, Rob, like, are you asking about like features of the cloud or this specific space?
The cloud, yeah. I'm assuming that this space is at least somewhat representative of the current state of features and stuff, or is there a lot more that this space is not showing us?
I think I'll go ahead and take the question. So Wonderland Cloud is more like an Amazon AWS. It is a very, very basic infrastructure where you can host any JavaScript code that you like. In this case, we're doing a virtual event, but later we might move on, or you guys might move on to a paintball multiplayer game that we built for VR. The thing is, you can use the server as ever you like. It's just going to handle all the WebRTC connections for you, potential WebSocket connections, and the audio mixing, which gives you a perfect base for any type of multi-user VR experience that you might want to do, even cross-platform to desktop and mobile. It's less a space like Mozilla Hubs. You can build something like Mozilla Hubs on Wonderland Cloud, but you can also build something like what's the
You got it.
Rec room?
Of
Oh
course,
no,
Rec Room.
he overloaded.
Yeah.
I can't hear Jonathan anymore, but
What was he gonna say?
I get what he's saying now. This is very interesting. Yep. Okay.
Any other questions or?
So with that in mind, would you say Wonderland Engine is now pretty much feature complete and like ready, or are you still developing things? And if so, what?
The Wonderland Engine or this
Wonderland Engine, yeah.
Wonderland Engine stays in development. There are constantly new features being developed in the engine, and that's this room is running on the render capabilities of Wonderland Engine.
I'm back, by the way. Sorry.
I
think my internet connection is not super stable. Good that it held on for so long.
A Wonderland Engine and Wonderland Cloud are two different things.
Oh, okay. Okay.
Where did I end up being cut off?
You were trying to think of the other example for what you could build on Wonderland Cloud.
Oh yeah, it's Gorilla Tag. So you could be building any multiplayer game as well. It's just the server infrastructure for connecting multiple people and doing spatialized audio.
Okay. So with that, is Wonderland Cloud, would you say it's pretty much feature complete now, or are things still being in?
Yes. I wonder if I got caught off again, but yes. So there's one feature that we're still working on with a bigger game where we need to kind of like spawn scalable rooms where currently we're inside one room, right? And we can add a huge amount of players into this room. But assume you have a multiplayer game and you want only 4 versus 4 people or 8 versus 8 people, then you might want to have multiple rooms with multiple maps that all use the same server but multiple instances of that server. That capability we don't have yet, but that's something that we're thinking about and probably adding eventually because we see it being used, for example, for the own paintball game that we might show you later on.
Mm-hmm. So with that, you're spinning up multiple instances of the server.
Yes, of the same server.
The same server.
Yeah.
Okay. And that so like whenever like you get 4 there on one server, or 8 if it's 4x4, and then when the next 8 join, they come up on a different server.
No, so generally our approach is that we provide very low-level developer tools. So we would give you control over when you spawn a new room. So you can decide whether, for example, a user wants to create a room, host a room, and then have his friends join or publicly people join, or if you want to handle the automatic creation of rooms yourself. So that's fully up to you. We'll basically just give you a REST API where you can say create room, destroy room, and this kind of thing, and it'll just create instances of the multiplayer server for you.
Okay, cool.
I have a question regarding that. If you can hear
Yep.
me, I'm not sure. Okay.
I can.
So regarding the voice mixing, you said that you provide a lot of low-level tools. Is there also a way to only include certain users in the voice mixing, for example, to allow scalability of like more than 30 users in one room in the future? Where, for example, more like an MMO style, if there would ever be like 1,000 users, but only like close people to each other could hear each other. Is there anything
We already do
around
that. So if you have a MMO scale world, then it would automatically do that. It only mixes to, I think, 10 meters or 15 or 20 meters. I don't know what exactly, and I think you can configure it to a degree. And it will also, depending on the current performance, will reduce or increase those limits to kind of achieve a certain kind of performance threshold that it needs to get to. Otherwise, the audio would start lagging. It can even drop back to panning if it notices that it cannot keep up performance on the server with full spatialized audio. But in general, we do a lot of things from just completely canceling out tracks that are just noise or are too low to actually matter, up to distance-based and all these kind of things.
Okay, that sounds very good. Regarding, for example, let's say in many applications you might want to use, you might want to mute a certain user. Would it be possible, or does everyone basically get the same audio stream?
No, so the muting button that you have hopefully on your screen or on your controller, that is implemented by sending a command to the server, and the server will then mute that player. I think you can mute on the receiver and the sender side. So you can say either, okay, this track is completely muted, either on the client side or no one hears this user. Or you can say, okay, this user doesn't hear this other user, and then kind of like very, very detailed kind of like control which mixes with what.
Yeah, okay, exactly. That's what I meant. Okay, thank you for answering.
Maybe one question from my side, if you can hear me.
I can.
So if I understood it correctly, the Wonderland Cloud basically handles like the server side, so you can combine it with like different engines or frameworks.
Yeah.
Uh-oh. Hello? Do we have a server crash just now?
This looks a bit like the server crashed if everyone's coming back. Okay, we'll have to look into the logs tomorrow. Okay, Adam, you're back. Okay, so the answer to your question, yes, in theory you can actually use any framework. We're a bit biased, obviously, because we also build Wonderland Engine. So currently, the only SDK that we provide is for Wonderland Engine, but you can indeed use anything.
Yeah. Okay. Cool. Thanks.
All right, I'll have to hop. So when you move on to paintball, please know that we currently have a server-side bug where we use Rapier for physics on the server to simulate bullets. And because we do mitigation of the latency, there's a very kind of game-breaking bug in there. I hope you still have fun for about 5 minutes or something like that and see the potential. Once we fix that bug, I think everything's going to be really nice and smooth. Nevertheless, it shows a bit of an example of what can also be done compared to this kind of more events-based use case that is more of a game-based use case. So it was wonderful seeing all of you again. I'm out. Hope to see you again soon.
Thanks for stopping
Bye, everyone.
Thank you.
Bye.
Thank you, Jonathan.
Bye.
Fingers crossed it will last more than 5 minutes. All right. Do we want to go ahead and get Nori's presentation set up?
Should we move on to the paintball example right now? I mean, just for
We have the
1 or 2 minutes
VRM
and come back here, or
presentation still.
do you
Yeah,
prefer
we can.
10 year maybe?
Huh? Can you hear me?
Let's go shooting.
Hello?
Can we just
Hello.
go
Can you hear me?
painting?
Sure. Let's go to the painting
Go-
and just click on the link.
We still had another
or you can
presentation.
just type the
Hello?
code right away.
Hello? Can I not be heard right now? Hello? Alright, I guess we're doing paintball.
If you click on the
Hello?
painting, you get
This is gonna sound very silly on the
pop-up
VOD.
that you want to, if you want to redirect, then it opens a new tab with that with a link to that page.
Source Scoot, can you hear
Okay.
me?
And which one? The Experience the First multiplayer WebXR game one?
Yeah.
Because they're all black for me.
They're all black. Oh,
Yeah, except for this screenshot from the escape artist.
yeah, that's it. There's a. Are you on desktop?
Laptop, yeah.
Yeah, in VR, it's a 3D image. So they're in the right eye, so it's actually 3D. It's really cool. But it's the painting next to it where everybody's looking at here in the corner.
Okay.
Otherwise,
excellent.
let me just share the link in the Discord as well. That might be.
Yeah, that's a good idea, I think. Yeah?
Yeah?
I can hear you.
I mean, we can come back.
Yes. Let's see.
it's on.
Welcome. Ready.
Yeah, we have voice too. Then we can call people back. Thank you.
I'm gonna keep both tabs open.
So how long? Does it get back in 10 minutes, 15 minutes?
That sounds alright.
Nope.
Ready.
Yeah, there's
It's,
a desktop.
Let's
mode
rock.
for it.
Let's rock.
But it's way more fun in VR. If you have the chance to play it in VR, it's way more fun. There are some technical glitches still in the game that can be really fun.
My God. Danger.
Oh wait, do I have to bring it back to the actual flag? Or did the round end? Or did someone take our flag?
Too big.
That was close.
Alright. I'm getting a little bit of rubber banding. Cool.
Okay, I'm back.
Okay. Get hop out of that. All right. Okay. Do I want to set up for the VRM presentation now? Is Ennis TCU here? I can still be heard, right?
Yeah.
Okay,
Yeah.
good. I feel like occasionally I like stop coming through and I have to like toggle the mic off and on again.
No, I don't know. I can hear you fine.
Okay. TCG, do you want to set up for Notary's presentation?
Yeah, sure.
Awesome.
Do we have everyone back?
I think we have most people back now. Or
There are some people
a
playing
portion.
basketball here. They're getting back.
Maybe can we do a broadcast or something on the channel?
And did you get all the permission stuff sorted out?
It should be fixed, yeah.
Okay.
Should be. I also hope so. Yeah, it doesn't show any errors, so I hope so.
All right.
Nari, just let me know when you want to.
Okay. No, that's no problem.
Yeah.
Is everybody here?
Sorry, guys, I have to drop out. Thanks. Bye.
See you,
Bye.
Jim.
See you, Jim.
Yeah, I think you're good to start.
Okay. You can hear me. Feel free to interrupt if not, or if you have any pressing questions. Yeah. So I was working on some inverse kinematics, and while doing so, I decided to use VRM avatars. But then the more you dive into it, the more you realize there is more to it than most people probably realize. So I thought, why not make it into a little presentation so that I can sort of share the basically an overview of what it entails, and perhaps get other people well eager to try it themselves or experiment with it. So yeah, and a bit of context why it might be even more interesting to dive into it now. About a month ago, there was this publication of the Kronos talking about the collaboration with the VRM consortium, so the people behind the VRM specification, basically trying to make it even well, a more official GLTF extension, basically trying to make it a well good standard for sharing and using avatars. So next slide, please. Well, the first question, most of you probably have some idea about what VRM is, and if you don't, well, here's their own definition. Well, quite simply put, a GLTF-based platform-independent 3D humanoid avatar specification and file format. So what's obviously, can you please go back to the slide? Yeah. So yeah, GLTF-based, as many of us know, especially when you're working on the web, WebXR, you'll often use like GLTF as sort of de facto the 3D model format. So it's no wonder that when you have an avatar, it would be GLTF based. But there's one thing that this definition sort of glosses over, is that what is actually unique to an avatar that you can't sort of have in a traditional 3D model. I mean, you could go to Sketchfab, look up some humanoid shaped rigged assets, and you could also download them as a GLTF file. Even if you sort of start reverse engineering the meta avatars, which I have, you will realize they also use GLTF with some minor extension, but mostly GLTF. The Ready Player Me avatars that we're currently using in this wonderful space is also shared to this experience as a GLTF file or DLB file, but basically GLTF. So on surface level, it's like, okay, a GLTF file is capable of holding humanoid avatars. So why do you need a different file format or different specification elements? And that's what I want to go over with you. It's basically the things that sets VRM apart from just a simple GLTF file with a humanoid skeleton. So if you go to the next slide, there are a couple of things, and I've ordered them in what I argue is the least interesting to the most interesting elements. And it's just a high-level overview of the features. If you want to know more about it, feel free to well look at the specification or ask me directly if you want to know something that I mentioned. But one of the first things that it actually defines is what it means for an avatar to have a first-person and a third-person view. And it might sound very simple, like third person, well, you see the whole avatar. First person, well, the most obvious mutation is remove the head. Because if you embody the avatar and you could still see your own avatar, perhaps you've seen it in video games from time to time where the camera glitches out a little bit and the camera is inside the head of a character. You quite often see some unsettling sight where you could see some edges of the contours of the face and the eyeballs. So a logical approach is to remove the head or anything that would obstruct the view if you would embody the avatar in a VR or even first-person flat context. On top of that, there's another element that they use to define first-person view, which I think is actually really interesting, is they have a way for you to define where on the avatar, relative to the head bone, the camera should be positioned in a VR context. Well, most of the time you could think, well, I just search for the eye bones, which is a good approximation, but doesn't always work ideally, or sometimes the eye bones can be further back into the head than is desired. So that's one of those small things where you already start to see, oh, it makes sense to have some additional information than just the 3D model. And the next point, if you could move on to the next slide, is materials, because avatars, well, they need to have a certain aesthetic, a certain appearance, and GLTF is mostly PBR based, physically based rendering. That's useful for a lot of things that we see around us in the world, but they don't really work in all situations. Now, the VRM specification originates from Japan, and they really like a certain aesthetic, a certain style, and they are more inclined to NPR, or non-photorealistic rendering. But GLTF out of the box doesn't really offer a lot of tools to create this type of look. So you could go with the unlit material route. I hope the screenshots come across good enough, but on the left you see an example of a avatar rendered with just unlit materials. So most shading or any color difference due to lighting is basically absent. It's just single flat color, consistent lighting. And on the right, you see it rendered with what they call the M-Tune material. So they defined the GLTF extension to allow basically a different type of material that aligns more with more cartoonish or non-realistic rendering. But it has a couple of elements that make it a tad nicer compared to a completely unlit model. For one, they allow outlines to be defined, a bit of rim lighting, so it also helps accentuate the edges and also the contours. And there's some stylized shading, so it's not completely unlit, so it can actually react to the environment that you're in. But I want to stress this type of material is not required for something to be a VRM avatar. If you look around, or if you have some experience with them, you will notice that a lot of them will use these types of materials, will use this type of style, but that's not a limitation of the specification. On the contrary, it's actually one of the strengths, because compared to just a normal GLTF file, which can only do unlit or physically based rendering, they added a third option, which is sort of in between, where it does react to lighting, but it isn't completely flat and unlit. Yeah, and then can we move on to the third amazing part? And I think this is something that if you've ever, been in experience like VR chat or Resonite or who knows what kind of social VR application, you will realize that besides just your inverse kinematics with your hands, perhaps even some more trackers or some approximation of your body, you want to have more ways of expressing yourself. A common thing is when you talk, you want the lips to move. So you have like physemes to follow a lip sync so that the mouth of the avatar matches a little bit with what you're saying. But you could also sort of have expressions that you toggle yourself, but can be used to signal, an expression. And I do them in the reverse order, I see, but that's not a problem. At the top, there's another element that's important, is the look at aspect and blinking. So it's somewhat unsettling if you talk to someone and they never blink. But in quite a few VR applications, you will notice that people don't blink. So a common approach is to have some blinking that happens over time. The same with people looking at a certain object. If I recall correctly, I believe AltSpace, before it got shut down, had a simple system where they would just blink, let the characters blink once in a while, but their eyes would actually focus on the nearest sound source, or the nearest avatar making sound. And some people were actually fooled into thinking that there must be some eye tracking going on, which wasn't there at all. It was just that people naturally looked at the people who were talking, and their avatars matched it because they implemented a simple system. But for something like that to work, you can't just take the eye bones from your 3D model and start twisting it in the hope that the avatar starts looking in the right direction. Now you need additional meta information to properly know the bounds of the eye. Like an eye can't rotate to look something behind you. And at the same time, sort of be able to calibrate and know how you can change the eye movement to match a certain look at target in the world. So these are types of things that the VRM specification allows people to define for an avatar, which you can then use in your application without sort of having to make per model adjustments or things like that. One thing I want to do stress, if you look at the expression presets, you see that they range quite in there's a big range in the types of things that they express. And on one you see, for example, the eyelids are half closed, but on the middle one, they are actually replaced with entirely different mesh. And the way this works is that the expressions mostly use blend shapes or morph targets, however you want to call them. But it does so with an indirection. So you have an expression that defines itself as a set of small changes that you need to make. And these changes could be setting certain weights on morph targets, but it could also making small alterations to colors or like UV texture offsets, which allows for interesting expression dynamics where you could, for example, if you would create a humanoid robot, you could decide to have like a faceplate that isn't actually humanoid eyes in that sense, but you could express or use the expression system to swap out the textures shown on the faceplate to match the expression. So one avatar might use morph targets to show expressions with their face, eyes, etc., while the other might actually use UV texture offsets to create, well, different texture elements shown on the head. And the neat thing is, it's all captured in the specification. So if you have an implementation or a runtime that supports it, you don't care whether the avatar uses one or the other system. You can support both without issue. And then to the almost the most exciting, not the most exciting, but almost the most exciting. So on the next slide, something secondary motion. Yeah, the video is just a to give a broad idea what it entails. It's basically a system that allows the avatars to define certain elements to be they call them spring bones. So they are basically bones as in your regular rig or armature, so they can deform the mesh. But the way they do it is by a sort of simplified physics simulation. So again, it's not meant to necessarily be realistic, but it's meant to give artistic control over how certain things move. So a common usage is, of course, hair, but the same can be done for clothing. So it's not a cloth simulation, but when properly constructed, it can create the effect of clothing moving based on the movement of the avatar. And similarly, accessories, etc. You can make certain elements of your avatar dynamic compared to a completely stationary setup. But now, arguably, in my opinion, the most fascinating and interesting and useful feature of VRMs is actually the meta information. And at first blush, it would seem very boring, like the name of the model, a version number is included, the author, copyright, like the basic stuff that you think file that's nice, but it doesn't have to be in the file. I mean, I could store it next to it. I could use it in a credits file. Who cares? There's a thumbnail image, could be useful, but maybe I don't need it. It just loads the file. But then we get to the point that I think is often overlooked and actually the most interesting and fascinating part of VRMs is they basically embed the notion of the license and the usage permissions. So every VRM 1.0 file actually links in their metadata to the VRM 1.0 public license. And that license is derived from the Creative Commons license. So it's a custom license that's based on Creative Commons. But instead of having the different forms like Creative Commons share alike, non-commercial, non-derivative, etc., these modifiers, whether you are allowed to change the avatar, whether you're allowed to reshare your changes, whether you're allowed to make it use it for commercial purposes, those are codified into the meta fields in the GLTF extension. So the license itself and the license restrictions and usages are basically all encoded into the avatar file itself. On the right, I've shown two screenshots of a website called Vroid Hub. That's a hub site where a lot of people can upload their avatars created with a certain avatar creation tool that supports VRM. But the reason I took these snapshots is because the fields or the conditions of use that they list are basically directly from the VRM file. And as you can see on the left is like the most permissive form you could have. Basically anything is allowed. You may use it with violence, with sexual content. You may use it as an avatar. You could use it for profit, etc. And you don't even have to attribute the creator or authors of the avatar. On the right, you see a more balanced set where someone says, well, this avatar I've created, you're allowed to do quite a lot with it, but you do need to attribute me. You're not allowed to modify it, and you're not allowed to redistribute it or any modification of it. And please don't use it for any sexual acts. So here you see that it gives the author of the model a lot of control over what is allowed and what isn't allowed to be done with the avatar. One thing to note is avatar use, and I think this is an interesting question that people don't often think about. But when you create an avatar that is sort of yours, so if you create a personalized avatar, you're in a position where you might identify as, oh, this represents me. So it makes sense that you wouldn't want to share it with just everybody, and definitely don't want to see your avatar doing things that you yourself wouldn't want to do. And avatar use is a broad term where it basically says, if I receive this file and I'm not the owner, am I allowed to wear this avatar, basically? So you might decide, okay, this avatar, I like it. I don't mind if people use it to create like interesting videos or maybe a music video, do some fun stuff with it. It's totally fine, but you're not going to around wearing it and sort of be me. And I think that's an interesting concept because you don't really see that in other avatar systems. At least I haven't encountered it, where there's a clear distinction between, oh, this is just a 3D model, do with it what you want, and oh, if you're gonna wear or be this avatar, no, please don't, because it's sort of, it represents me. I don't want it. And I think that neatly ties into the next slide. And this comes from a presentation the VRM consortium did on SIGGRAPH Asia 2019. And there they said that their vision VRM believes that world is a better place if you can bring your avatar to wherever you want to go. Well, it manages to fit in the you and your word 3 times. But if you can go to the next slide, that's actually the important difference, like the most important difference I can think of if you think about VRM avatars as opposed to Ready Player Me or even meta avatars or to some extent Pico avatars, is there's this big concept that you own the avatar. So on the one hand, you create an avatar. The current, I know this listing is very incomplete, but on the left side, a common approach is using it in Unity and using the UniVRM extensions and plugins to export the avatar. There's VRoid Studio, a pretty popular approach, software to create VRM avatars. And the output is a .vrm file that you own and can do what you want. And then with that avatar, you go to all sorts of applications that would implement VRM support. There could be online VR applications, could be tools for like virtual cameras or live streaming purposes, could even be games that support VRMs as playable characters or whatever they decide to do. But if you compare this, for example, to meta avatars, well, you put on your Quest headset, you create an avatar, and you can use them in games. So you have to create in a multi-use somewhat covered. But the point where you think, do I actually own this avatar? Well, you probably don't, because what if you want to use your V2 avatar of the Meta Quest? Well, since they, if you've migrated or converted your avatar, you're not getting your old one back. If you want to use it on a desktop completely separate from your headset, for example, to do a Zoom meeting with a virtual camera or something, well, you can't really do that because no, it's locked into the ecosystem of Meta. So you do have to create a multi-use in different avatar systems. But the notion that you actually own the avatar and actually have it as a physical file that you can just drag and drop in many experiences is missing. And that's something that sets VRM apart, really sets it apart if you ask me. But on the next slide, it's not all glorious and nice. There are some arguably big challenges if you want to use VRMs in your own experience or implement support for it. The first one, as I mentioned before, the standard originates from Japan, but you also see that a lot of the design decisions, a lot of the documentation is Japanese centric. That isn't necessarily a bad thing, but it is a bit of a hurdle. Like if you read the documentation, your options are either machine Japanese, assuming you don't speak or read Japanese, of course, or try to make sense of the English versions whenever they are there. But these aren't always the most readable. But it also shows itself in different contexts. For example, with the lip sync, with the blend shapes for the mouth shapes, those are traditionally Japanese mouth shapes. I don't know. I'm totally not up to scratch what every language has in terms of mouth shapes and expressions, but it's a relatively limited set that seemingly aligns good with spoken Japanese. But for other languages, including English, it's very common to have a different set of mouth shapes which aren't codified in the specification. There's some limited tooling around it. As I mentioned before, common approaches are like the UniVRM extension, so a lot of Unity-based support is there. Luckily enough, there is a semi-official 3VRM extension. So if you use 3GS, there's actually pretty good support for importing VRM files. There are very few constraints, and I don't mean it constraints as in terms of the specification or schema, because that's pretty well defined. It's more that it tries to be multi-purpose. Like as I mentioned, you could use the avatar in all sorts of contexts. Like it could be a VR application where you use the avatar. It could be like a virtual camera. It could be in a game. It could be for creating some photos or whatever. But you might have different requirements for those. So what you will see a lot for virtual cameras or live streaming purposes, they actually have higher fidelity models. So a lot more blend shapes to make different faces or to use your webcam and then reconstruct your face pose, etc. But it also means that if you have a avatar, a VRM avatar that's geared towards that use case, you will often have files that are way larger and actually models that are not performing all that well on a mobile chip, for example. Where inversely, if you really have a mobile avatar or avatar geared to mobile purposes, it might not work as well in a different context where you need or want the higher fidelity. So I think that's one of the challenges that you'll find is there is no, because if you compare it with Ready Player Me or Meta Avatars, there are clear budgets in terms of the number of polygons, the number of texture sizes, or the texture atlasing support it has. So you sort of, if you support the Ready Player Me avatar or if you support the MetaQuest avatar, you know that you will support pretty much any Ready Player Me or any MetaQuest avatar. But if you would have VRM support, there's no guarantee that you can support all of them. Well, on a technical level you can, but on a practical level you might not. And the final challenge, which is just an annoyance, I would say, is there are two versions of VRM going around, VRM 0.0 and 1.0. And the first one is still more prevalent and more common. They are mostly convertible from one to the other because they codify the same information just in a slightly different structure. The 0 version didn't really follow the GLTF extension practices, so it did some wonky things that it doesn't in 1.0. But that does mean that from the outside you can't always see which version you're dealing with. But my solution to these challenges, or at least my advice would be, if you could go to the next slide, is just start building and using it. If you're interested in integrating an avatar system, I think now is really the time to focus on VRM and try to make the best of it. And the more people use it and contribute and give feedback back to the specification and the consortium, the more we might be able to find like the best way to use it or try to address the pain points. Because that's the thing, it's a specification, but it's also something that's still being worked on, still being developed. And if we would sit around and wait till it either wins or loses out, instead of trying to already use it, identify the pain points and try to contribute back to the specification, we're doing ourselves, I think, a disservice. Because this is one of the few avatar formats that's also, because it's GLTF based, also very suitable for the web. And the final slide, a bit of the story how I ended, because it's really a rabbit hole. As I mentioned, I started with trying to implement an inverse kinematic solution. Then I decided, well, let's do VRM avatars, which turned into, well, I miss some tooling. Let's make a VRM validator, which I already had made in the past, but not really fully fledged and updated. But I thought, let's update it. And while updating, I realized, well, not all models are optimized enough for my liking to run it on the Quest standalone in WebXR. So I wanted to use the LTF transform to do some optimizations, but then I realized, oh, some of these destroy the VRM metadata because it doesn't know about these extensions. So I actually started another project, VRM transform, which implements support for VRM extension in GLTF transform. And then I noticed, well, just with these modifications, I'm not getting to the performance levels I want. So now I'm improving the performance of the official Pixif 3 VRM library. And I'm making some good progress, I think. So I think it just goes to show that there's a lot of things we can still improve about VRM. But I think the promise is there. A promise that I don't see in other avatar systems yet. And I would love to see it expanded and perhaps even convert meta avatars or Ready Player Me avatars in the VRM file format just to show like it can do it all. But the only way to find out is just to start building and using it. So that's my presentation. Thanks.
That was awesome. Thanks.
Really cool.
Thank you.
I'm curious how. So it looks like you kind of went on a little bit of a yak shaving journey, but how far along did you get with that IK solution?
Yeah, so the for those who have seen the tweet or post I shared about it, I shared it also in the Discord channel. That's I currently have a system where I just take the headset and the controller and or hand positions and mostly apply it to the VRM avatar structure. That works decently well with the arms and the neck, etc. Where I sort of end up is the posing of the feet and the legs, because I try to estimate where people would place their foot, and that's like doable, but you will always find counterexamples, and I think that's true for the whole inverse kinematics. There, you will always be able to come up with a counterexample where it just completely mismatches what you're doing in real life. So my goal is more that it's a plausible pose and a okay looking pose over a matching pose. Uh, but I made some good progress on it, but it's not yet in a state where I can release the source. Yeah, one thing that's clearly not yet implemented is integrating it together with locomotion, because now it's purely based on physical movement in the space. But ultimately, with locomotion, I want to have the leg movement pinned down a lot better, because it just shouldn't look off. It should look possible.
Yeah, foot targeting is just like one of those like frustratingly like under-documented aspects of VR avatar like stuff, especially for WebXR, since really the only examples we have are like ExoKit's avatar system, which works even with locomotion, but the leg movement looks wonky. And then
I'm into that.
And then I think there was also, I've seen examples of people porting Final IK, using Final IK in a WebXR thing, which is like the only other major example I can think of.
Yeah, I'm currently trying to do not really base it off either of those, partially because I think one of the design goals is also to make it make the approach at very least very straightforward and simple. So I try to build it up from very rudimentary but logical assumptions. And one thing I would try to avoid with the legs, but I might have to do it, is sort of I don't want to predict where the user is going to place their foot. I really want to base it on where it could be. But then you run into the issue where it will start lagging behind. Pun not intended. But if you decide one leg needs to take a step, if you would then pinpoint the end position of where it would place its foot, you would completely miss the boat if the person keeps rotating or moving in a way that the foot position would actually be further along. So I found that when I decided a step needs to be taken and I still allow for adjustments during the step, it would seem mostly normal and okay, because people can't really discern if a step starts whether it was intended to be a longer or shorter step really. And then you could still sort of close the gap between the actual spot it lands and the actual spot it should be a moment later. But you're still, with fast moving situations, it's still tricky, and you might actually want to overshoot or predict based on the movement.
Gotcha. Any other questions on VRMs?
One thing that I'm
So-
curious about, like how the hair system works. Like, is it some sort of physics? I'm not sure.
Yeah, so the hair system, so any secondary motion, so the hair is not different from the clothes or the accessories. It's one system. The way it works is these spring bones, as they call them, are defined as a chain from one point to another. And the base of the chain is basically fixed in space, but every next bone or point in the chain is indeed sort of moving based on a simplified physics system. They use Verlet integration, which basically means for every frame we base its new position based on the previous position. So they incorporate inertia, drag, and gravity into the calculation. And the gravity one is a substitute for also external forces. So you could simulate things like wind or other movement in there as well. But the key point is it's not a full physics simulation. It doesn't try to be realistic. So it gives the artist a lot more control. So for example, you could have one strand of hair where the artist says, well, I want it to sway when the character moves, because that's the neat thing about secondary motion. It's added a lot of liveliness to a lot of people, even if their movements are perhaps a bit crude or limited, because, well, in most VR contexts, you don't have a lot of information about how the person moves outside of the head and the controllers. But the secondary motion livens it up a bit. But an artist could, for example, say, well, this strand of hair, I want it to sway a little bit, but I don't want it to move too much. So it could make the impact of gravity less. Or it could say, well, these joints are have a higher stiffness, so they have a more resistance to moving. So it's a simplified physics system with a lot of artistic control. That's the way you could see it.
Nice. I'm also curious, like how it would look like in an integration standpoint. Like all this data is inside the VRM file, or we have to do it in the engine or framework.
Well, the VRM file itself has just the definition and the configuration of what is what the aspects of the hair strands is, etc. But any runtime that implements it will have to keep track of that state themselves. But the neat thing about the chosen approach for the simplified physics, is that with Verlet integration, because it bases on the previous value and the current value, you don't really need to keep a lot of state. So the state is really codified by positions in space. So if you have your scene graph, the joints of the hair strands are, if you place them in your scene graph, that's all you need, because during your update you move them, and then in the next frame you can just derive them from the positions that you have. So there's actually very little state that you need to keep track of. And one thing that might be interesting for you is, for Wonderland Engine, I actually did write the VRM component a good while ago. So there is some implementation there.
Yeah, I am aware, and thanks for that.
Any other questions?
Yeah, I guess that clarified my question. Thank you.
Okay.
Any other questions? I think Adam, you had one.
Yeah, just a quick question. Do you have some Twitter or something where we can follow perhaps how it's how it's going the development?
Yeah. So I have a Twitter account. It's just yeah, Nouri Huisman. But if you on the well, what's the easiest way? I'll just share it on the Discord meetup channel. I don't post all too often. My intention is always to post more. So it might not be the most interesting place to follow. My GitHub could also be a good point to follow if you're really wanting to be kept up to date. But any big achievements, I'll be sure to hopefully tweet about.
Hi, Plume is not allowing without signing in.
I will say, whenever you do post one of your demos, those always seem to do pretty well.
Yeah, but that also that creates a situation where you'll think like I can't just post anything willy nilly.
Yeah, no, I get that.
No.
All right, cool. So yeah, I've got to run. So see you later, guys.
Okay.
Bye bye.
Ciao.
See you. Thanks for stopping by.
Bye.
Alrighty. I actually also do need to hop off for a bit, so I will go ahead and cut the stream now. If people still want to hang out, that's totally cool. But I need to run.
Yeah.
It was nice seeing everyone. And thank you for offering the space for this month's meetup.
No worries. Precious hours.
All right. I will see you guys around.
Bye now.
Ciao.
Oh, we can hang out here if anyone